Passas a minha apresentação. Okay.
Mas olha, eu não consigo ver ninguém. Quando é que eu começo?
Podes começar tipo daqui a 5 minutos ou assim.
Ok. Então eu vou contar 5 minutos. Hi, everyone, and welcome to this talk that is a partnership between Data Science for Social Good Portugal and NILG.AI Consultant that is our partner. I'm going to start by talking about our formula in Data Science for Social Good. we join together beneficiaries that can be charities, non-profit organization, or public administration that has this non-profit character. And we join them with volunteers, and volunteers from our community that can be from data scientists, data enthusiasts, data developers, designs, and domain experts. And joining them, we want to accomplish projects. And these projects are with a duration of 3 to 6 months, and they are intended to be simple, yet impactful. So we do want to give a deliverable, something that these non-profit associations, these beneficiaries can take into account and lever their activities. Talking about the projects that we have accomplished in the past, we have done a project with Rotaract Santo Tirso and Liga Portuguesa contra o Cancro. And in this project, we intend to explore the variables that influence more the fundraising for the cancro. And for example, we could see if in the supermarket or in the street, which location contributed more to the fundraising, and in order to optimize in the future. In the ongoing projects, we have Associação Portuguesa Zoófila. Their mission is to provide medical care for all the animals, even if you don't have the monetary the money to do it. And here we study the variables that influence the waiting time. We want to reduce the waiting time in order to actually schedule more appointments and do more treatment in a more efficient way. Also ongoing, we have a project with Associação CAIS, and in this association that is very known for everyone and just accomplished the 25 years of their magazine, we want to do a storytelling of how the selling of their magazine actually influences the sellers, how it helps. And with this, we want to impact and raise awareness on future campaigns. The next project that we are going to start, we hope very soon, is a project with Fruta Feia. Fruta Feia is a non-profit association that gathers vegetables and fruit that have less, that are not in the parameters that the big supermarkets want. For example, the small can be too large or too big or too small. And we want to optimize the basket content to take into account the delivery constraints of a certain week. And to make this happen, we need your help. And how can you help us? We can be part of the project, as I just mentioned, with these non-profit associations. You can also join one of our mini projects. We started these mini projects when we did the ongoing repository for COVID-19. And these are short term, they are not actually associated with any specific beneficiary, but we do use data for social good. Also attend our meetups and talks and workshops like the talk that we are doing right now to raise awareness for data for social good, or you can be a data for good ambassador and with helping us bridge this gap between us and your organization. Also, you can help in other ways. For example, you could help us with being a tech partner, providing cloud service and training instances, for example, or a data partner sharing the data with us that we can use in future projects for social good. We can be event partners, for example, in venues and coffee break service. Now, unfortunately, we are not getting together presentially, but we hope that in future we can do it again. Knowledge partners, like in workshops and trainings, or even to be a project patronage and banking up the expenses that the project can have. Don't forget that you can follow us in all these social media networks, Twitter, Instagram, Facebook, and LinkedIn, or you can write anything that you want and we can respond very shortly to our email hello@dshg.pt. And without further ado, and Francisca is really the star tonight, she's going to talk us about fairness and AI, a very dear topic for everyone that works in this data science for social good, because we do want to tackle every bias that are present in the data and in the models, and she's going to explain us more about how we can do it.
Thank you for the introduction. Hi, everyone. Thank you for being here today. My name is Francisco Morgado. I'm a data scientist at NILG.AI. And in the next hour, I'll be talking a bit about fairness in AI. We'll start by understanding why is this a concern in data science community. Next, we'll define fairness in machine learning. Then we'll see some methodologies that we can use to promote fairness in our solutions. And finally, we'll look at some practical examples. So why fairness? For decades, we've been trying to teach algorithms human knowledge, and more recently with AI, we're trying to make them learn like the human brain does. So we feed them with data and transmit them our priorities and our principles. However, if we as humans make some decisions based on unfair principles, we will be also transmitting unfairness to our systems. And here you can see some examples of this. The first example is an algorithm used in some American courts. This algorithm was used as a decision support system to evaluate the criminal risk of a defender, and it was biased to black defenders. This algorithm used to attribute a higher criminal risk to black defenders. The second example is an algorithm of automatic sentiment analysis. They used to rate sentences such as "I'm homosexual" or "I'm black" with a negative score. The fourth example is an algorithm of automatic translation that has a gender bias. When translating a sentence like "she works in an hospital," "my friend is a doctor," from English to Portuguese or to Spanish, it assumes that the doctor here in the sentence is a man. However, if we try to translate the sentence, "she works in an hospital, my friend is a nurse," the algorithm assumes the nurse as a female. And if you try the other way around, using "he works in an hospital, my friend is a nurse," it will assume that the nurse is a male, which means that with the male, the algorithm got the context of the sentence, but here, using the female and using the word "doctor" is not getting the sentence, and it assumes that profession like doctors are occupied by males. And the fourth example is an algorithm used in an online shop. They used to display different prices depending on people localization and the distance of those people from a rival store. Well, most of the unfair cases are caused by the presence of some bias. So it's important to be aware of what kind of bias might disturb our systems. Here I'll present you 4 types of bias. Historical bias, that is related with types of discrimination that were considered normal in the past, as gender and racial discrimination, for example. You can see also population bias that occurs when an algorithm is not adapted to new populations. We also have observer bias that happens when an observer projects his or her expectations onto the problem, and then it picks the solution that best suits the initial goal instead of suiting the real data and the real problem. And we also have measurement bias that occurs when unfair features are used as proxy labels. One example seen in real life is using family criminal records or friends criminal records as a proxy to measure the criminal risk of an individual. But these are just a few examples of all kinds of bias that exist. Here you can have an idea that there's a lot of kinds of bias, that can be integrated in our data or in our algorithms, in our system. So it's important to be aware that they exist. I won't extend more on this topic by now, but you can check these definitions in the paper referred below. An important thing to understand is that unfairness is not only related with data, and if we are not aware of where the problem might be, we can generate a bias loop. So we should look at every step of the process, like the problem for information, the data set construction, the algorithm selection, training process, the testing process, the deployment, and ask ourselves if we are being fair in all these steps to avoid this bias feedback loop. So now we know that models can be unfair, and we want to change that. But what is the definition of fairness in AI? Well, the definition can vary depending on on our problem and what we want to guarantee. For example, we can define fairness as equalized odds, and here we want that protected and unprotected groups should have equal rates for true positives and false positives. But then we can opt to see fairness as equal opportunity, and then we want that the protected and unprotected groups should have equal true positive rates. We also can see fairness through awareness, and here any two individuals who are similar with respect to a similarity metric should receive a similar outcome. So there are more definitions that you can also explore in the same paper, but it's important to define what is the unfair problem in our model or in our project, and then define what metric or what fairness do we want to achieve. So, how to ensure fairness in machine learning? I'm sorry. As we saw in the bias feedback loop, we should be aware of this problem in every step of the way. So, for example, when we participate in the data collection, we should rethink this process and aiming to have representative data sets, avoiding unfair features. We should ask ourselves if our historical data generated by bias processes, if our labels reinforce any stereotype, and other questions like that. Then we can also act on the pre-processing step by trying to transform the data set, removing underlying discrimination, and try to balance the representations. We can also act in processing, which is modifying or creating algorithms in order to remove discrimination during the training process. And one example here is adding a fairness regularization in the loss function, for example. Or we can also act in the post-processing step. And here we can use fair metrics to choose the best model, or you can use a second model fed by the predictions of a black box, and then we ensure fairness in this second model. Or you can use the predictions of a normal model, and then rethink our decision process using fairness priorities. But now I'll focus on the third step, the in-processing step, and I'll give you some examples of how to modify or how to build algorithms that guarantee fairness in the training process. I'm sorry. The methodologies that I'll present you are all related with adversarial learning. I'm sorry. In this slide, we can see adversarial debiasing network, and which is a very simple methodology. Here we have a pair of models. The first model is the predictive one, the one that is solving our problem, and which is fed by our feature space and try to predict the label of a sample. And then the authors added a second model, an adversary model that uses these predictions or the last dense layer. For example, if we are talking about a neural network here, and based on this output, try to predict the protected space or the protected variable. And here we are talking about the feature that causes discrimination. For example, gender, local birth, something like that. So the aim here is to maximize the accuracy of the first model while minimizing the accuracy of the second one. So we want good predictions, but we don't want that this model to be biased. So we guarantee that these predictions are not related with the protected groups. Here you can see the results. In this paper, we are talking about a gender bias. Without this adversarial debiasing network, the difference between the false positive rate and the false negative rate of female and male were really high. And with this method, the authors were able to make them closer. The second method I'll present you is fair guns. Guns are used to generate artificial data by adding noise to real data and then passing that artificial data to a discriminator that should split real samples from fake samples. This gun is a little bit different. Here we have two discriminators, and what this gun is intending to do is creating artificial data based on the real data and based on adding noise, and then it tried to fool the two discriminators. This discriminator is the one that splits the real samples from the fake samples. So when this generator is able to fool this one, it seems that you have fake data that is really close to the reality of your data set. And here the second discriminator tries to split samples from protected groups, from samples to unprotected groups. And by fooling this one, you're guaranteeing the bias generated data. So the authors use this fair gun, to generate artificial data, and then use that artificial data to feed the predictive model. And here in the results, you can see two graphics. The first one represents the risk difference, which is related with the discrimination, and the Euclidean distance, which is related with the distance of between the real data and the fake data. And as you can see, this in this axis, we are looking at the lambda of the fair gun. So when we increase that lambda, we are decreasing the discrimination, guaranteeing that our generated data is very related with the real data on the data sets. And in the second model, you can see that by decreasing that discrimination, the accuracy is no changes or small changes. So you're not compromising the accuracy of the model by using this generated data, artificial data. Okay, the third method is a little bit different. Here the authors try to achieve fairness by explicability. They use CHOP values to measure the relevance of the protected features, or the Z features, and then they define two fairness by explicability metrics. And what these metrics want to represent is the difference of the Z group relevance between the protected groups and the unprotected groups. And you know that an algorithm is fair when this difference is minimized. This second metric measures the attribute of Z across the population, which is trying to minimize also the relevance of the protected groups. How did they implement this? They add a regularization factor in the loss function, and this regularization factor could have was written in two ways, in two methods, with SHOP squeeze and SHOP enforce. Here the equations are a little bit different, but but they have the same goal, which is minimizing the Z relevance. Okay, we'll look at the results now. Here we can see the results of SHOP squeeze for 3 different data sets. And we can see that increasing the lambda, the model was able to decrease statistical parity difference and also decrease equality of opportunity difference, which are fairness metrics. And also we could decrease them a lot from 0 to 0.9 and still have a decrease on accuracy and on area under the rock of 0.04. For the SHOP enforce, we can see that this method also decreased the fairness metrics, which ensures fairness in the model, but it did it in a faster way. But here the area under the rock dropped by 0.03 and the accuracy by 0.008. However, we can find a middle point here that decreases the unfairness and also does not compromise the accuracy of the model. So these are pretty good results. Okay, now we saw some examples or some methods that we can use in processing. Now we'll see some practical examples of unfair situations and how to deal with it. Okay, I will start with an example from literature, and then I'll show you a couple of examples from NILG.AI. In this case, the authors of this paper found a bias in education recommendation systems. Here, these systems were recommending STEAM courses, which stands for Science, Technology, Engineering, and Mathematics. They were recommended STEAM courses to boys easier than to girls, or more frequently than to girls, even when girls express interest in this kind of courses, the probability of being recommended to STEAM courses was lower than the probability of recommending boys to these courses. So here, the authors saw that the problem had a biased data set with imbalanced representations of female and male groups, and also historical bias in the recommendation algorithms. What they did, they defined 5 fairness metrics that you can see here. Value unfairness, which measures inconsistency in sign-in prediction error across the user type. Absolute unfairness, similar to the first one, but does not consider the direction of the error, which means then that if you have a positive error for boys and a negative error for girls with the same value, the absolute error, absolute unfairness will be 0, which does not represent very well the fairness in the problem. Here you have also underestimation unfairness that measures inconsistency in how much the predictions underestimate the true ratings. Overestimation unfairness that does the opposite, and non-parity unfairness that measures the absolute difference between the overall average ratings of disadvantaged users and advantaged users. What they did was generate artificial data sets using uniform and unbalanced observations probability and unbalanced and balanced representations of female and male groups. They train a matrix factorization algorithms for recommendation systems, and they train it without regularization and with regularization on each of these 5 fairness metrics. And at the end, they tested the algorithm, evaluating the error and the metrics on the 5 fairness metrics. The conclusions of this use case is that regularizing one of the metrics, one of the fairness metrics, tend to decrease the others. So we don't need to use all these metrics in regularization. We only have to pick one of them. They also conclude that decreasing fairness metrics did not did minimize the prediction error. So in the other cases, we are trying to not compromising the accuracy or not compromising the error. Here, the authors were able to maximizing the accuracy of the model with fairness methods, and also that regularization with the value and fairness was the most effective. So if you are thinking of trying to solve a problem like that, maybe this will be one of the best metrics to apply on regularization. Okay, now we'll have an inside look in NILG.AI. Here we'll talk about 2 projects, one with mobile ODT and the other with Tristle. Both are in healthcare industry. With mobile ODT, we're trying to promote fair access to high quality healthcare. And here we had a portable and small medical device, and we wanted to give decision support to medical personnel. But the goal for this device was to be used worldwide. So we had to guarantee representation of a lot of communities in our data set, and we also had to guarantee that there was no bias between them. But if I'll explain more in the next slide. But if we want to know more about this project, we can also go to this link and see our talk in the Symposium of Bioengineering. In the TriStol project, we want to track a disinfection process. So we'll be filming the process and giving real-time evaluation of the process with errors or with guidelines for the next steps. And here we'll be filming the arms of the personnel. They will be disinfecting the medical device, and the environment, the table where the disinfection take place, and things like that. So we integrate the data collection step, and here as a fairness with a fairness practice, we try to guarantee difference of gender, race, age, and other skin factors as moles, tattoos. And we try to include all of them in our data set to mitigating this bias that could be related with our skin. And also we try to add a great variability of staff skills and room conditions, because we don't know if the materials that are being using in European hospitals are the same that are being using in African hospitals or American hospitals. So this could generate population bias, for example. But also, if you want to see more about this project, you can go to this link and check on the innovation in medical device decontamination. Okay, about the first problem, where we had different populations, we realized that we had been biased, and that some populations were being related with some kind of outcome. So to suppress that, what we did, we trained a model per group or per population, and then for each new individual, we compute the outcomes for every trained model, and we compute an average of the outcomes to get our final prediction. And in this way, we were able to minimizing the population bias in our project. So yeah, that's that's all. Thank you for your attention, and I'm open now for any question.
Thank you, Francisca. You can ask any question in the channel and we will show it and Francisca will answer. I'll just start by thank you for the presentation. It was really nice. I personally learned a lot about these fair.
Oh.
I learned a lot about these fairness metrics. And let me start by asking you, because you said that, of course, all the steps in the process from data collection, data preparation, and you focused more in the literature in processing. Which one has the most impact when we are dealing with this bias? Because as popularly we say, when we have bad ingredients, it's difficult to make a good cake. So if the data is so bad curated, is it possible to still take the bias and make models that are not biased?
Well, that's what these methods were trying to do. Sometimes we have data sets with a huge amount of features, and sometimes we don't even know what those features are. So, yeah, we try to bake those cakes with any eggs that we have, even if there's any trouble with that. But of course, we should be aware of this problem in every step, as I said, and I don't think that one is more important than the other. It depends on the problem. It depends on the type of bias. Of course, that if you're using a data set which the features are all biased, well, that's the problem is on the data, of course, and there's nothing you can do in processing or in post processing. But all of them have a lot of relevance in AI problems, and the ideal situation is to be aware and to mitigate the bias in every step. So look at the data set, if it's possible, collect new data, more representative data, and then clean your data set, remove the samples with bias or transform it, and then train assuring that you have no bias and so on, so on. That would be the perfect world, but unfortunately, sometimes the worst part is to get the data and collect the data. So we have to figure out how to run our models, how to get our algorithms with the data that we have.
Yeah, but even the data, how we curate these data sets, like I was talking with you in the beginning before we live stream this event, the confidence that we access the bias, so these estimations is very important as well, the uncertainty, because we can have, if you have a very small data set, maybe we are not getting the right magnitude of the bias that we could have if we have a bigger data set. Because if the bias is very extreme, maybe a smaller one is enough. But if it's not, we should pay attention to this uncertainty and how these parameters are being estimated. But for example, it made me think also in the different phases of taking the bias that, for example, in NLP, we can also do data augmentation. For example, with the nurse being a male, being a female, we can do the duplicate, putting a male instead of a female in that sense, and then MT systems are less biased, which are very interesting.
Yes, and when you were talking about using a small data set to represent a big population, here you can, maybe you have a problem of subgroup population. So with this small data set, maybe there's no bias at all, and they are representing the population properly. But if you don't know which population it is, you don't know if you can use it to run an algorithm in a different population, because those features could be different, and then you will assume biased features related with localization or with a restraining group, and you'll try to apply it on a new group, and that's also an unfair problem.
Yeah, of course, we need to be aware of the bias itself, because
even
otherwise it's very hard to remove the bias if you are not aware.
Even if it wasn't an unfair problem at the beginning with that compilation in specific.
Claro. Yeah, of course. We still don't have any questions, but if you are there and if you want to ask, don't feel shy. Francisca is eager to answer any of your questions. I don't know if you want to add anything. We have a question from Pedro Oliveira. Fairness or ethical AI, yes.
Well, when we think about ethical, we are also thinking about fairness, but here we are thinking about the first step of the AI process that you can also consider as the last one in this loop, which is do we should use a model to solve this problem? A model will be ethical to solve this problem, and this rethinking steps, they're also related with fairness in AI. Here you cannot measure it in the sense that you have to think how, if you're using an algorithm, how the decision process will be. Are you going to prioritize unprotected groups at the end? Are you going to make human decisions instead of trusting only in the predictions from an algorithm? Ethical is related with this problem, of course, but it's not. Well, it would be better if you give me a practical example, because ethical could be so many things. But yeah, if sometimes you have to rethink if an algorithm is an ethical solution for your problem, and sometimes you have to stop there because simply it isn't.
We have another question. Sorry, you want to complete or?
No, we can go on.
So we can go for this question from Maria Vitória Jorge. She asks what we do when the human is not aware of the bias. Are there tools or techniques that could be used to detect it? It's a very good question.
Well, to detect the bias, you can use explicability methods and try to when you measure the relevance of each feature, you analyze those features. You have to question yourself if that relevance is matching your expectations. If you see that a gender feature, for example, is very relevant in the problem of
like you said, choosing a course.
Yes, in the course recommendations or applying for a job, and if you see that those metrics have an expected relevance, probably you have biased features here and fair features here. Another way to solve the problem is trying to clean the data set and try to make the groups more balanced, even when there's no idea about about if they are protected or unprotected groups. But yeah, with explicability, I think it would be easier to analyze those danger features.
Yeah, I just remember, for example, if you are doing an NLP task, And even if you are not aware in the beginning of any bias, when you are looking to the embedding space or when you are looking if two words have a similar, more similar than any other words, maybe that's also an alert. If you see that if the embedding from men to like medical is much closer than from human to medical, like you said, like we were not aware, but we know that some features should not correlate with our final result.
Yeah, it's very important to look at our problem and look inside each step. We cannot use machine learning algorithms as black
Like a black
box.
box. Exactly.
We have to understand them. We have to refine them. So we have to be aware of what's happening in each step and be prepared to detect those bias or those unexpected results that might have a biased situation or an unfair situation as the as the initial problem.
Exactly. Be critical with the tools that we are using. And for example, I will just remember coming back again, because I think that the data itself is very important. If you are using, for example, a model that was trained in a data set, maybe try to think how was that data set created if the model is learning things that shouldn't. For example, I was just reading an article in a couple of days ago, that it has a higher frequency of mental illness words and topics, and also criminality. And of course, if the model learns that these two might be correlated, when we are, for example, using sentiment analysis or toxicity models, it might give a higher value to a sentence like "I have a mental illness," and that is not fair. So we should analyze every single step.
Yeah, and there's a lot of correlations of that type with historical correlations, racial correlations, and we should stop our algorithms in those steps to guarantee that they do not assume that as fair correlations that they should look at in new data.
Of course, new well-curated data. I don't know if you should wait for any other questions. Feel free still to ask. I personally am not remember of any. I found it very interesting, the different kinds of fairness metrics. I was not aware, and it was good to learn that.
The fairness definitions or the metrics?
The metrics themselves.
Okay.
Yeah. But maybe if you don't want to add anything, maybe we'll close the session.
If anybody has a question, I'll be happy to answer. But
I'm saying that there is some. We have another question. Okay, let's see. So Felipe asks, for instance, sometimes it is difficult for us in social projects to make decisions on how to help. Who should we help before? Do you think there is a potential for a model to be fairer than ourselves? That's a very good question.
Well, this is a complicated one. It depends. What are you looking for in making these decisions?
For example, in our Data Science for Social Good Association, we often need to choose if we should help this association or this one. And for example, we have now ongoing case with the CAIS, and maybe in that data we also have some social bias, because historically maybe some racial problems. Is there any, I think the question is there any model that could help us to be more fair with ourselves and with our analysis?
I think it is possible to create a model that could be more fair than ourselves if you try to teach the model and give them the correct data to make a decision. For example, If you want to help an association, you'll probably ask yourself, okay, this association, what's for this association? Is it helping someone? How many people is helping? Maybe this value will be influencing that. What's the goal? If it's for health, it's for education, if it's for culture, you can try to give some points for these areas. And of course that sometimes we have personal preferences, and if we don't give them to the model, we can expect an outcome that is more fair than ourselves.
But yeah, and also the ethical, like you're saying, like how many people it affects, it starts to enter more in the ethical than in the fairness in this case. Felipe also asked or comment, hi Felipe and Catarina, currently I first met Francisca in Rotarac, which is also known by the SSG. So I'm curious with your opinion about the potential of using AI models for social purposes.
Well, of course, as a data science and as a person that integrated movements like Rotaract, I would love to see more examples of these two areas together: social good and artificial intelligence. And yes, I think that we can build fair models that are more fair than ourselves. And I know that AI can help us a lot with time-consuming tasks, and sometimes the volunteers are just a few, so any help is a good help. So of course,
in all the steps, even just awareness of how AI and data science can help these non-profit associations are useful.
Even small algorithms, for example, I know that Rotaract Santo Tirso used to distribute food to a lot of people in the city. I'm not sure if it was just inside the city, but also outside. And sometimes small things like an algorithm that will optimize your trajectory for food distribution will be a help. Will helping you in this goal. So of course that you can join both things and you can have a better result with that partnership between AI and social good.
Yeah, and talking about food, we have this fruta feia that is not optimizing the trajectory, but like what food should be in each basket, trying to minimize the food waste and reaching more people that need, especially now into the pandemic.
Yeah.
So I think we should end. I think it was a really good talk. Thank you, Francisca, for your words and your comments. And for you that are listening, if you want to join any project or help in any way, it's Life for Social Good, or to know more about NILG.AI, feel free to contact either me or Francisca or the company or the association. Thank you.
Thank you very much. Bye.
Bye.